Welcome everyone to another video where we are going to solve problem number 19 from second chapter, Force Vectors in the book of Engineering Mechanics, written by R.C. Hibbeler, the statics part. So in this video we have been asked to determine the resultant of these two forces, the forces Fa and Fb, which are acting on the plate as shown in this figure. Theta angle is given, which the Fa is making with the y-axis, that is 60 degree. So our goal is to determine the magnitude and direction of the resultant by these two forces. So let's solve this problem. For determination of magnitude, we will be using cosine law. For that, the resultant is being calculated by formula as Fa square Fb square 2Fa Fb cos alpha, let's say. Alpha here is the angle between these two forces. I mean this angle. This angle is not directly being given, but we can calculate. Theta is 60. So 60, 40 will make 100. And the total angle between positive y-axis to the negative y-axis is 180 actually. So if this is 60 plus 40 is 100, then remaining will be 80 degrees. So cos alpha is actually 80 degrees. So simply we will put the value of Fa, Fb and alpha in this equation to get the resultant of these two forces. So putting these values, we are going to get the resultant as 10.8 kilonewton. This is one of the answer which we were looking for. The other is its direction, which is measured from positive x-axis. For that we are going to use sine law. Now in order to use sine law, we need a triangle formed by these forces. So we have Fa and Fb force. We will displace one force and we'll keep the other force. Let's say we are keeping Fa force and we are displacing Fb force by putting the tail of Fb force with the head of Fa force. By doing so, the closing side will then be resultant. So this side is Fa, this side is Fb, this side is resultant. We are interested in determining this angle, the angle which the resultant is making with the y-axis. For that, if we would be successful in determining this interior angle, then we will be able to determine this angle. So this angle is angle of our interest. Let's say the angle is x degrees. So sine of x degrees will be divided by the magnitude of the opposite side, that is Fb, which is 6 kilonewton. So divide by 6 equal to, now in this triangle we need a interior angle which should be known to us. This interior angle cannot be determined because we don't know the direction of Fr, but we can determine this interior angle with bit of geometry. So let's draw the imaginary lines here. So this is imaginary x-axis and this is imaginary y-axis. So this theta is 60. So therefore this angle up to y-axis the Fa force is making will then be 30 degree. So if this is 30, the opposite side will also be 30. If this is 30, so this will be 60 then. And how about the Fb force which is making with the y-axis, which is known here, 40. So the total is 60 plus 40, 100. So sine of 100 divided by the magnitude of the opposite side, which is Fr. And we previously calculated the magnitude of Fr, which was 10.8. So we'll simply put 10.8 here. So from here we can determine the angle x. So on doing calculations, we are going to get the angle as 33.16 degrees. This angle is not angle of our interest, but we are actually looking for this angle. So I previously mentioned that this angle is 30 degree. So we'll simply subtract 30 degrees from x. We'll get beta, let's say, which the Fr is making with the positive x-axis. So on subtracting, we are going to get 3.16 degrees. So this is what we were looking for. That's the other thing that was required in this problem. We now have determined the magnitude of the resultant as well as the direction of the resultant. So that's all from this video. I believe I tried my level best to convey the solution of this problem. If you feel any difficulty in this problem, just let me know through the comment section. I'll try my level best to answer your query. That's all from my side. Thank you very much. I hope to see you in next coming videos. Till then, bye.